Hey guys, and welcome back to another Fusion 360 video. Today we're going to be having a look at a few more advanced tools on Fusion 360 while we go through the process of making a machine bolt and a nut to go with it. So I hope you guys are looking forward to this. We're going to have a little bit more of a look at the Revolve tool. We're going to use a section analysis. We're going to use a thread tool, and we might, even if we get time, put an assembly in. So sit back, relax, enjoy the video, and hopefully you guys learn something. So without any further ado, let's get into it. So we're going to go across to Create Sketch, and I'm going to select my side face here. I'm going to get a rectangle. I'm going to go out 5 by 50. All right, done. Then I'm going to set another rectangle from the top here, and I'm going to go 10 by 10. So I get this nice square finish. I'm also going to fillet this corner back. All right. I'm going to give it about a 5mm fillet for now. I think that will be nice. From there, I'm going to grab the trim tool, zoom in, and snip out the lines that I don't need in the middle. So that's all done. What we've just done here is we've made a quarter profile for our bolt shape. And now if we finish the sketch, we can simply revolve this shape around the back line to make our bolt. And I'll show you what that looks like. So we use the Revolve tool. We have our profile selected. And then we select where we want to rotate it around. If you've guys seen the short, you know that if I click somewhere, it will rotate this shape around to make a 360-degree object. So if I click the back edge, it will rotate that whole shape around to make a 360-degree cylinder, basically, which is starting to look a lot more bolt-like than our initial drawing. If I'm going too quick for you, feel free to slow the video down. And if you guys haven't seen the last video, you might want to jump in and have a look at it before you follow along too much further if you're getting lost already. So now I want to make a way to turn this bolt, because obviously we want to be able to tighten our bolts up. So I'm going to create a new sketch on that very top circle of it. And I'm going to make this an Allen key driven bolt, which means that I want to put in a polygon, or a hexagon to be more precise. And I'm going to make it a 5mm hexagon. So you can see I can type my figure in and I can adjust how I want the hexagon to sit. I can also, in this edge number box here, change how many edges it has. So right now it's 6 because it's a hexagon and that's what I want. But if I wanted a 5, if I wanted a double hexagon, I could go 12. And you can see there's 12 edges in there. It's a bit hard to see because it's sitting directly over that circle. Or if I wanted 5, I could change it up there. So you can change how many you want, how many faces you want for any other jobs. But for this, hexagon is our best bet. Now that we're done there, we're going to finish our sketch again, hit extrude. Now, notice how it hasn't grabbed these corners. It's made them as a separate body, so you're just going to have to make sure that you click all of them, and you'll know if you haven't, because it'll look real funny. Alright, but now I've got everything clicked. It looks like a nice solid blue hexagon, and I can just type in -5, because I want to cut this into the top. And you'll see that I get this nice hexagonal piece in here. Now, it looks like my drawing has a little bit too much meat on it, but what we're going to do is we're going to check for our section analysis and make sure we've got enough strength. So to do that, we go into our utilities menu over here, and we have a section analysis tool. So I can click on that and click on a plane, all right, and it will cut it in half. And you can see that I've got a fair bit of meat in there to work with. So I could make that hex bigger, or I could take a couple of mil off this overall head width if I wanted to save a bit more weight or a bit more material. But this section analysis is really, really handy to see where everything is. All right, I can move it, so I could move it out a little bit if I don't quite want it there. Having it in the midpoint is actually really handy. I can also adjust the angle of it. All right, depending on the sort of shape you're running, you might need to change that up. But for me, I'm really happy with how that is. Hit enter, and that's there. If I want to turn that section analysis off, I can click that button there. So I can just click on and off just to see how everything's going as we're moving along. Now that we've worked that out, we're going to jump out of utilities again, back into solid. Hit my home button just to clean up my view a bit. And we're going to do one more thing before we put the thread on. All right, if you guys have ever worked with bolts, nuts, or anything like that, you'll know that they have a slight chamfer on the end, just to make sure that they start nice and easy and we don't get any issues later on. So to do that, we go into our modify plane here, hit chamfer, click the edge, type in 1, hit enter, and we've got a chamfer on there now. I'm pretty happy with that. Now we just need to put a thread on it. So to do that, we go to create, thread, and click the surface. Now, it looks like a thread, but at the moment, all that does is it throws a texture of the thread on there. It doesn't actually make it in. And I've made this mistake my first couple of times doing this, gone to print something, thinking that I have a thread on it, and it doesn't actually have a thread on it. You need to tick this modeled button here so it actually puts the thread in the model. Now, I'm just having a look down the bottom. All right, we'll have a work on that in a minute, but you can see I get the option for what type of thread that I want. All right, I could run it as a self-tapper or a pipe thread or any of those sort of things. I can go into imperial. There's so many options. I'm just running the metric profile, and it's an M10 by 1.5. I can adjust that, so I can take a pitch down a little bit. So if you know anything about threads, you know that the second number there is the pitch, or how high the thread is, or how fine the thread is. All right. If I turn on my section analysis, it's be a bit more visible for you guys. So if I go like this, and I change that pitch, so I'm at 1. If I go 1.5, you can see that the teeth become bigger and the grooves become bigger. All right. Or I can go down to like 0.5 and you can see it's a really, really, really fine thread. I'm going to be honest with you guys, if you're 3D printing this into plastic, you're going to probably want the biggest, coarsest thread that you can manage, because a 3D printer, it prints pretty well, but printing this sort of detail, it will struggle, it will make a little bit of mistakes, so the coarser the thread is, the easier it is for the printer to run it. Alright, so that's about it. You can change the direction too, you could put it as a left-handed thread as well, but once we've done that, we hit OK, turn my section analysis off, and we can see we've got this nicely threaded bolt. But, looks like my chamfer's mucked up the bottom there, so what we're going to do is we're going to move this chamfer on the timeline to after the thread, and that basically means that it did the thread operation before the chamfer, and it looks a lot tidier now. Let's just put that sectional analysis back on, and you can see there's no big lumps or grooves, whereas before, when I had it over here, you could see that there was this part here which didn't quite line up with the thread. So that was going to make the nut really hard to start. So if I move that chamfer to the other side, it just makes that go away, and it just makes it look nice and threaded. So this is your timeline, by the way, and we're going to delve into that now. Turn my section analysis off because our bolts are done. To adjust something on your timeline, you can simply go along there, and if I find something that I want to change, I can click into here, and I could say change this to a radius 4 mm. All right, not a huge change. Alright, but I've changed that to R4. Alright, pretty easy. Nothing super strenuous there. But now if I hit finish sketch, it goes all the way back to the end, but it's changed that through the entire process. So if you make a change in your timeline, then it affects everything after it. So just bear that in mind. And if you find later on that you've made some mistakes and you want to change something, you can do it. All right. But you're just going to have to remember that you're going to have to go through and check to make sure there's no errors generated from any of the things that you've done. But that's the bolt done. All right. We've still got a little bit of time left in this video, so we'll quickly make up the matching nut. So this is an M10. So we obviously want to make sure that our nut is the same. So we're going to go create new sketch, bottom plane. I'm going to draw it a little bit offset. And I'm going to draw a polygon. If anyone knows, most nuts are, what was I going to say? Most nuts are hexagonal. So I'm going to make sure I've set it up. I'm going for a 10 mil radius, so that's a 20 mil size nut. That's a bit big. I'm going to go 9.5. All right. That gives me a 19 mil outside face, which if you know spanners, 19 mils is standard size, 20 isn't. You can get 20 mil spanners, but they're a bit harder to find. All right, done that. And now to save myself doing a hole later on down the track, I'm going to put the hole in now. And I'm going to make my hole 8.5. The reason for that is, and I'll show you in a second, I can extrude that up. Let's make this 10 mil high. All right, so we've got a big nut. When we did this thread, it was an M10, which means the outside points of it. Where's my section analysis? There it is. Oh, visibility. So that means from the outside point here to the outside point over here is 10 millimeters. All right. But the inside point to the inside point, because it was an M10 by 1.5, is 1.5 millimeters smaller. So that inside to inside there is 8.5 millimeters at the moment. So to make it matching, you need to make sure that you adjust your hole size accordingly. You'll also see that my section analysis applied to this shape as well, wasn't sectioning anything that goes along that blue axis. All right, let's turn that off again. And now we can simply add our thread in. All right, we don't add threads going substantive, so we're going 10. It's an M10 by 1.5. We want to model it. And we hit OK. And we should have a nice thread there. Now, stay tuned for the next video. We're going to animate these two pieces together. We're also going to render them so you can put a realistic texture on them so they don't just look like a grey blob. Until that time, make sure you like and subscribe these videos. Whilst we are posting heaps of content up now, just getting ourselves off the ground. Once we get a few more subscribers, hopefully we can get some more detailed content and start showing you guys some whole project views. So please make sure you hit that subscribe button if you want to see this channel grow and see a few more videos that are going to help you guys out. Until next time, make sure that you do that, and I'll catch you in the next video.